be solving a projectile motion problem. So the problem is a water balloon is launched off of a cliff's edge at a velocity of 20 meters per second at 50 degrees. If the cliff is 40 meters tall, how far from the bottom of the cliff will the balloon land and explode? Can a person standing 100 meters away from the bottom of a cliff get hit with the balloon if the angle is changed but the velocity it is launched at stays the same? So first we're just going to focus on the first part of the problem. So we're going to make a diagram for it, that's the first step, and we're going to fill in just what we know. So we know that the cliff is 40 meters tall, we know the balloon is launched at 20 meters per second at 50 degrees, and we know that the value that we're trying to find is from here to here, from where the balloon lands, so that we're going to call x. The next thing we're going to do is make a chart showing the horizontal and vertical components of the problem. So we know that it's going 20 meters per second at a slant. So in order to find the horizontal velocity, all we have to do is do a trigonometric function. So it's cosine of 50 equals x over 20, and we find out that the initial velocity horizontally is 12.86 meters per second. And now we know that going down a cliff like this, the balloon is not going to accelerate, at least horizontally. So we could fill in the acceleration is 0 meters per second squared. So if there's no acceleration, that means the final velocity is still going to be 12.86 meters per second. Then vertically, to find the initial velocity, we could do sine of 50 equals x over 20, and that equals 15.32 meters per second. This is a free fall problem, so that means that there is an acceleration, and the acceleration for free fall is always negative 9.8 meters per second squared. So that means we do not know the final velocity yet. And then we could also fill in that the vertical displacement is 40 meters. So now, using this information, we're going to find what the time it takes is, because it's going to be the same here and here. And then using that, we'll be able to find the distance from here to here. So to find the time, we're going to use the time equation, which is time equals final velocity minus initial velocity over acceleration. So because we don't know what the vertical velocity is at the bottom, we cannot use that in this equation. However, we do know that at the highest point, the vertical velocity is 0 meters per second. So we could use that as the final velocity and just find the time from here to here first. So we'll plug it into the equation. So the final is 0 minus the initial, which is 15.32 meters, and we'll do it all over the acceleration, and we'll get 1.56 seconds. So that is only the time from here to here. It's not the total time. And we still don't have enough information to find the total time. So now we have to find the displacement from here to here, so then we'll be able to find what the time it takes to go from the very top to the bottom is. So to find that, we'll use the displacement formula, and we'll plug in our values. So the initial velocity times the time it takes to here, and plus 1/2 times the negative 9.8 meters per second squared times the time squared. So 1.56 squared. And that gives us an displacement of 11.98 meters. So that means from here to here, vertically, is 11.98 meters. So that means that the total displacement from the very bottom of the ground to the highest point is 51.98 meters. So all we have to do is add those two to find that. So now using that, we could find the time it takes to get from here to here. So we could use the displacement equation, and which is velocity initial times time plus 1/2 acceleration times squared. So this time we're going to use this point as the initial velocity because we're going from here to here. So since it's 0, we can completely cross that out, and our time equation will be 2 times displacement over acceleration, and that is all under a square root. And we could solve that to find that the time from here to here is 3.26 seconds. And then after that, all we have to do to find the total time, so we have the time from here to here is 1.56 seconds, and the time from here to here is 3.26 seconds. So all we have to do is add those two times together to find the total time, which is 4.82 seconds. We can now fill that in on the board. So we filled that in on this side, and the only thing the same on these two different components is the time. So we could also fill it in on this side. So now we have enough information to find the horizontal displacement from here to here. And that will solve the first question of the problem. So now we could use the displacement formula to find the horizontal displacement. So this is the formula, and we know that horizontally there's no acceleration, which means this whole thing we could cancel out because it would just equal 0. So all we have to do is plug in the initial velocity times the time and cancel out the seconds, and we get that the displacement is 61.97 meters. We could fill that in on the chart, and that's our final answer for the first part of the problem. Now that we solved this, we could start all over to solve the second part of the problem. So our second question is, can a person standing 100 meters away from the bottom of the cliff get hit with the balloon if the angle is changed but the velocity it is launched at stays the same? So again, we're going to start with a diagram. So we know that the velocity it's getting launched at stays 20 meters per second, and we still know the height of the cliff is 40 meters. So we could plug in what we know again. So we know the acceleration horizontally is always 0 meters per second squared, and we know that since this is in free fall, the balloon's acceleration is going to be negative 9.8 meters per second squared. So now we have to decide which angle we're going to use to see if it could hit someone 100 meters away. So the angle that can make the balloon go as farthest it can possibly go is going to be 45 degrees. So we could use that angle and find how far the balloon could possibly go, and then we can compare that. If it's less than 100 meters, we know that it cannot hit someone 100 meters away, but if it's greater than 100 meters, that we know that at the right angle it could hit someone who is 100 meters away. So we could fill in the angle, and then we could use trigonometric functions again to find the initial velocity horizontally and vertically. So plugging it in, we find that horizontally the initial velocity is 14.14 meters per second, and we know since there's no acceleration, it's the same here. And vertically, it's also 14.14 meters per second. And this is kind of an explanation of why the 45 degrees is the best. It's because the horizontal and vertical components for velocity are the same, so it's going to go the farthest at this degree. So now this is exactly like the problem before, and we could do the same process to find this and see if it could hit something 100 meters away. So now we can use unit analysis to find the time it takes from here to here, and we use the time formula and this as the final velocity. So we find that the time it takes from here to the highest point is 1.44 seconds, and then we could find the displacement from here to here, and we could use that so that we could then find the time it takes from the highest point to the very end. So we'll use the displacement formula, and we'll find that the displacement vertically from here to here is 10.20 meters. So adding that to the 40, we know that this entire displacement is 50.20 meters. We could then use that to find the time it takes from here to here. And since we're using 0 as the initial velocity now, we can cross that part off so that this is our whole time equation. So now in the equation, this 50.20 meters now becomes negative because it is going downwards. So the displacement is negative. And we find that the time it takes from the highest point to the bottom is 5.12 seconds. To get the total time, we could add the time from here to here with the one that we just found, and we'll get that it's 6.56 seconds. So that's the total time for both sides. So now we could find the horizontal displacement, and that will give us our answer. So we could use the displacement formula, and since we don't have an acceleration, we can completely cross that part off because it would just be plus 0. So finding that, using unit analysis, we find that the horizontal displacement is 92.76 meters. So this tells us that the balloon, the farthest it could go at this degree of 45 degrees, is 92.76 meters. So it would not be able to hit someone 100 meters away, but it would be pretty close. So it would be pretty close. So that means that at this velocity of 20 meters per second, it cannot hit someone 100 meters away, and that's the answer to the question. So that's all there is to solving this problem. Thank you for watching.